Hey, it's Kevin Lawton with the New Warehouse Podcast here at MODEX 2020. It is day 3, and we are in Atlanta at the New Warehouse Podcast booth. I am joined by Lior Elazary, who is the CEO and founder of InVia Robotics. Lior is going to join us. He's going to tell us about InVia, tell us a little bit about how they were one of the first with Robots as a Service platform, and talk about a little bit about his background and how he came to actually found the company. So Lior, welcome to the show. How are you?
I'm very good. Thank you very much for being for inviting me here, Kevin.
Okay. Well, I'm here.
Yeah, I know. Thanks for being here.
We are being here together. So it's all good. So tell us a little bit about your background, since you're the founder of InVia. So tell us, I guess, about your background and how you actually came to found the company.
Okay, cool. So my background, I'm actually a serial entrepreneur.
Okay.
Founded several companies before, 3. In particular, first one was HostPro, actually turned to be web.com.
Okay.
And then later on, it was KnowledgeBase, was a CRM solution.
Oh, interesting.
And then the latest one was EdgeCast. It was a CDN. I don't know if you guys are familiar, but basically,
CDN. No, I don't think so.
Content distribution network.
Oh, okay, interesting.
In fact,
we know content.
Yeah, exactly. Well, you might be transmitting some of the stuff of our servers, or used to be our servers now
Really?
It's Verizon.
Okay. Interesting.
It's actually pretty interesting because I think what's happening in the in the e-com and the fulfillment world is sort of what happened with data.
Really?
So so what a CDN does is it enables you to really move data as quickly as possible.
Okay.
And actually beat the speed of light. And it's because, again, people are a bit impatient and trying to watch their YouTube, and if you're waiting more than 10 seconds, you'll just go somewhere else.
Next thing.
Exactly. So in the old days, you used to have just one server in one location, kind of like a DC. And then when you try to get it from China, if you're in the US, it just took too long for people to get the data. And again, when I mean too long, I mean seconds, but that was too long.
That's too long, yeah.
So in order to solve that, we basically put servers all around the world, hundreds of thousands of servers. So when you're viewing a particular data content, you're actually looking at the content that's right next to you.
Okay.
And I kind of joke around because I guess my job before was to transmit content faster than the speed of light,
right.
And now I got to transmit atoms faster than the speed of light.
Right. Interesting.
So basically, I think the same thing is happening with e-com.
Okay.
Right. If you want to get your package within a day, an hour, even 2 days.
I want it in seconds.
Yeah. Well, exactly. I think people are pressing the envelope.
Oh yeah.
You're not going to get it from China, right? If you're ordering something from China right now, it's going to take months until it gets over here.
Yeah.
So the way, pretty much Amazon is leading the way in that particular space is by placing warehouses all over the country, all over the world. And then when you're ordering something, it's basically coming in from instead of a
down
huge
the street.
DC.
Yeah.
Exactly. Some driver will come in, drive it by. So that's what's happening. But that has created a lot of pain points for everybody else, actually including Amazon. Amazon is still, trying to, I wouldn't say figure it out. They've figured a lot of good stuff.
Right.
But they, if you look at their financials and how much money they're spending on fulfillment, it's still a really big portion of it.
Definitely.
And they're extremely optimized. They have, I think, about 200,000 robots right now running around.
Yeah. All those keyboards, right?
Yep.
Yep.
But from the reports I read, only 30% of the warehouses are automated.
Interesting.
So yeah, and that's sort of been the problem. So for a lot of our customers and people we've talked to, that was one of their biggest pain point with automation. Is that it's really a construction project.
Yeah.
You gotta wait 2 years in order to get something done. Kiva as well. Like you gotta start with mirror finished floors. You gotta redo everything, redo the shelves.
Yeah. It's not necessarily something that's easily dropped into an existing layout.
Exactly.
Yeah.
And that's just been a pain. And it's not just a pain to do that, it's also extremely difficult to predict what volumes you'll have 5 years from now, 10 years from now.
Yeah.
Because when you're building that, again, it takes you 2 years to build it.
Yeah.
You actually have to build it for peak, first of all, because nobody else can really access that, that environment that you're building, so that piece of automation.
Right.
And one of the issues is that a lot of our customers, especially e-com, 1 month out of the year is their busiest month. In fact, 4 to 10x some customers are doing.
Yeah.
And then for the rest of the time, they're just
it's not so busy.
It's not as much. So it's very difficult for them to justify automation and to install something. And again, something that you got to predict what your peak volume is going to be 5 years from now.
Okay.
And I think this is why we actually don't have a lot of automations in the warehouse. If you look at the majority of the warehouses, 90% of them are actually not automated.
Right.
So one of the most exciting things that's happening with robotics and with particular types of automation is their ability to adapt to the warehouse.
Okay.
So in the past you had to adapt the warehouse to the robots. That was the construction project. You install rails, you install guides, and that was the shuttle systems. And again, talk to a potential customer, spend $150 million on a particular installation.
Wow.
That it's out of reach for the majority of the people. You got a handful
unless it's like the Amazons only, basically.
Exactly.
If you've got the extra cash laying around, you can do it. But for the smaller guys that are trying to keep up with the big guys, it's unreachable. Yeah.
And it's not even the smaller guys.
Yeah.
It's everybody below Amazon.
Right. Yeah. Basically. Yeah. I mean, when I say small, I don't mean like mom and pop. I mean, it's just that in between, and I think it's crazy because you're trying to keep up with this precedent that Amazon has set, set, and it's kind of hard to do. Very hard to do. Yeah.
I mean, one of the things that Amazon has, talking about them, they actually have a secondary source of income, which is their AWS. That's doing actually pretty well.
Right. Yeah.
So they're able to use that to kind of fulfill the
to supplement everything else.
Exactly.
Yeah,
and when we talk to some of the the customers, they're like, look, we don't have that.
Right.
If we start losing money on this fulfillment stuff, Wall Street is going to kill us.
Definitely.
So we got to figure it out, and that's what basically everybody's trying to do now.
Right.
So one of the so we founded InVia Robotics actually specifically to solve these pain points.
Right. So how did the so you did the CDN and did knowledge base, and knowledge base I've heard of actually, and so how did the pivot to robotics? Then come.
So I actually always was interested in robotics. Ever since I was a kid, building robots. Went to USC for school to work on different robotic projects. But every time we started a business, it was really difficult to make the business model work.
Right.
We in now in 1870s or whatever, when we first started with the word robots, everybody thought, all right, in the 2000s, we're going to have robots running everywhere, doing everything. And we sort of, getting there, but it's not what they thought it's going to be.
Yeah.
And one of the reasons is actually cost that a lot of people don't realize. So when you look at some of their robots and their capability, the capability to their cost is extremely, extremely expensive.
Okay.
If you see, Boston Dynamics, great company, really doing a lot of great research in that field, but when you're looking at some of the robots and, if the robot costs, I think now they're selling it for $30,000-$40,000.
Yeah.
And it can open doors. You have a person that works for $20,000 to $25,000 that not only open doors, does a lot more.
Right. Actually, they had the little I forget the name of
dog.
The dog-looking one over there. Which we posted to Instagram. Somebody sent a message and they're like, "What's the point of that? What's the use?" And I said, "Oh, it's for people that want a dog but have allergies."
It's a cheaper alternative, which is a little puppet. But sorry. So really, like I said, so when we looked at the stuff, we looked at the various. So this is right after EdgeCast.
Right.
We're kind of looking at where robotics will make sense. Our initial thing was like, hey, let's do robotics at the home.
Okay.
That's pretty cool. Everybody wants a robot in their house and work around. We actually, before at USC, built a bunch of prototypes. In fact, we worked on a project called the DARPA Robotic Challenge. Okay. I don't know if you've heard of it, but
no, I don't think so.
It's a really cool challenge. I think this is where really government spending is worthwhile. So DARPA really set the bar very high. What they wanted to do was to have a robotic. I wouldn't say necessarily have to look humanoid, although a lot of them sort of did. But a robot that'll be able to go into a disaster area, get into a car, drive the car, clear a bunch of rubble that's in the space, open up a door, walk through the door, climb up a catwalk, find a valve, turn off the valve, go find a drill through the hole, go down the catwalk, find a jackhammer, break through the wall, walk through, get in the car, and drive back. So you're like, wow, this is, and they really pushed the envelope.
Yeah.
And when we first worked on it, we're like, oh, look, even battery life itself, it's not going to have been sufficient to do this.
To do all that, yeah.
Let alone like the actual complexity of building a robot to do this.
Right.
And then they took some stuff. They're like, well, all right, well, let's make it semi-tail operated. You can do some stuff, but you're going to have noise in the system. So basically, you're not going to get constant feedback.
Right.
But then even that was too much of a challenge. Even getting into a regular car, so they switched it to a UTV. Going through the doors was extremely difficult. So what they ended up doing is just breaking the task into one task after the other. But the coolest thing is they actually had the whole competition up in Anaheim.
Okay.
And they brought the public, so everybody can come in and see the latest and greatest. It was like watching paint dry. And if you search on YouTube for DRC, you will find, YouTube does a great job on finding all the failures in the robots. So it's...
well, YouTube I think, loves failures. So,
yeah, exactly. So after you watch that, I don't think anybody's going to worry about any robotic apocalypse or anything like that. All I have to do is put a small rock in the thing, it
just falls over.
Yeah. So, but at that program at USC, I actually worked with Dan Parks and Rand Voorhees, my two co-founders right now. And like I said, initially we're like, wow, great. If we could do something like this, let's try to apply it to the home. And we started looking at different business models and seeing how we can do that. This is where we first came up with the RAS, the Robotic as a Service. We decided that, technology by itself is, it's not complex. There's a bunch of moving parts, but there's still things that go down. Like you have servers that like I said before with Edgecast, we have a bunch of servers, and you still have issues, right? Even in the old days, right, for email, people used to buy their own server and set up their own email account, and you have to hire an IT person to deal with that and deal with all the issues. Now you just go to Google. They deal with all the issues for you. So we thought, okay, the same thing is going to have to happen with robotics, because it's a machine. There's going to be some failures in it, and somebody has to deal with it. And if you have it at the home, you're not going to hire an IT person come in and debug.
Right. Yeah, you're not going to hire somebody with a PhD in robotics
exactly
to your house. Yeah.
So that was one of our initial concepts. This was, I think, back in 2014, 2013, 2014, that will, if we do something, it'd have to be robotic as a service. And that it would be sort of what DARPA did, which is, have the robot have the ability to really transmit a lot of information, a lot of data, and have it, be able to fix things remotely. Because we're not going to be able to have somebody, on the floor, but having somebody remote will be able to actually maintain and support this robot remotely. Now, we never did anything with that because just the unit economics didn't make sense. We thought, okay, we could maybe get a robot to operate, maybe do about 20% of the home, pick things off the floor, cook by taking a microwavable food out of the freezer and put it in the microwave. And that was sort of the extent of it. And that was really challenging. In fact, for us too, we had some prototypes. Just going through the door was like extremely challenging.
Was it because it kept like bumping into the door, or
it's
just
tough.
that?
It's like it's finding the door, being able to autonomously open it, close it. There's a lot of mechanical movements that you do when you open the door that you don't realize. And then you have to move around because you have to get away from. Because if you open the door right into you, you're not going to be able to walk. So you got to walk through and walk to the side.
You got to like step to the side. Yeah. Oh yeah.
But so we thought we could be able to achieve that, but the robot will probably cost $40,000 to $50,000. The problem with that is you can hire a person again for $24,000 who does 120% of the work. So we thought that there'll be a few people who love robots who will buy it, but it's just not going to scale.
It's not practical.
Now, as we were ordering parts actually for some of the stuff that we're prototyping, we're ordering it all from Amazon. And we were getting it prime overnight, which was amazing because it allowed us to prototype and build things extremely fast. If a part didn't work, the next day we had the next part.
You didn't have to kind of wait and like stew over your idea, like, because you're probably excited, I imagine, too. So you want it right away.
Exactly. And if there's a failure, and with 3D printing, we're able to actually create a lot of mock-ups. I had a plasma cutter, so we were able to actually create some stuff, create some initial prototypes. And we were ordering these aluminum sheets, 8-foot by 4-foot aluminum sheets from Amazon. And it came prime, individually wrapped. We didn't pay anything. I mean, we paid $100 a year, but we completely abused them. And we were like, how does Amazon do this? How can they afford sending 8-foot by 4-foot aluminum sheets individually wrapped, and started looking at their financials and saw that, they're spending a lot of money on the fulfillment. They're, making that up.
Yeah.
And through Edgecast, I actually had a lot of e-com customers, because a lot of e-com customers actually want their site to load fast and everything. And we started going and talking to them and seeing what their pain points are.
Right.
And some of them have invested in automations and, great millions of dollars. And I asked them, what's your ROI on it? They're like, don't ask me. And the next warehouse, they never really did another automation.
Right.
And then other ones were like, look, we don't need the automation. We can't find the ROI initially, so we're not even going to do anything, and they just used labor. So I was like, okay, well then what are your pain points? And they did say it's actually labor.
Right.
And labor in different areas. So one is obviously picking, which is account for almost 50% of their pain point and 50% of the work inside the warehouse.
Definitely.
And here we're talking about e-com. So e-commerce, where it has a very unique picking kind of style than, for example, the traditional retail.
Right.
So you don't ship 1,000 units of the same SKU. You're shipping 1,000 SKUs of one unit.
Right.
And you have to go and fetch for it inside the warehouse.
Yeah, in all different locations. Yeah.
Exactly, and it's all randomized. So it creates a lot of pain point, and people often don't like doing this. And most of the customers we talk to had almost 100% turnover. So people only last 6 months to maybe a year.
Yeah, it's just it's so monotonous, and it's taxing sometimes too. It depends how it's set up. Of course, if you're walking a lot and stuff like that, and people don't want to do that forever. Yeah.
Exactly.
Yeah.
So we looked at different options, and one of the options we actually had was a runner to kind of, just put, have the robot go from point to point, but you still have the person walking around. This is sort of similar to some of the models that are actually out there today. But the same deal, we actually had a hard time making the unit economics work for that, and we thought, look, we really need to eliminate the walking completely. Like no person can walk at all inside the warehouse if this thing really needs to succeed. So this is where we created our InVia Robotics and created the robot, which really is a goods-to-person system. Is able to go in and manipulate items at the end and bring it over.
Okay.
And what we do, we call it gross manipulation. So we manipulate boxes, whether it's corrugated, plastic, and we could work with any kind of shelf system. Okay. But we don't do the fine manipulation, which is extremely difficult these days. That means you're digging inside the tote and doing something or packing it. And that's again, when I say difficult, it's both difficult in terms of technology, but also in terms of cost, right? Making that thing cost correctly, being able to justify. So we developed actually the first prototype, had it running inside a warehouse within 6 months. And it really became a huge success. And we were able to really solve a lot of the pain points for our customers. And it wasn't just solving the one pain point, which is the picking. It was also solving the replenishment and cycle counting and really handling all the inventory and movement inside the warehouse. One of the biggest pain that we noticed was during replenishment. If a person makes a mistake and you got 100,000 SKUs and you put the tote in the wrong location, that SKU is lost. Yeah. And for all intents and purposes, you can imagine, several football fields, big, of just racks. Oh yeah. And they ask you to find a SKU. Again, good luck.
It's very difficult. Yeah. I come from inventory control background actually. So I mean, it takes like 5 seconds for someone to make a mistake. Yep. It could take hours, maybe days, maybe months before you actually find the product that you lost from the mistake. Yeah.
Exactly. And it's not just finding it. It's now that the picker goes out there and he's more likely to make a mistake. And he'll grab the wrong item.
In the wrong location.
Yeah. And then he goes into the pack station and the packer now is slower because they have to QC and it's the wrong one. And then they put it down on the whichever one they picked wrong, they just put it what we call the wall of shame. Actually, a term that one of our customers used, which is where all these products that they have mistakes with, end up.
It's kind of like this little black hole, right?
Exactly. Yeah. And nobody wants to put it back because that's more labor.
Yeah, because then they got to research it and figure out where is it actually supposed to be, and nobody's interested in doing that.
Exactly. And not only that, it's actually costing him money because now that picker his effective throughput was actually lower, even though his throughput might have been somewhat decent, maybe at about 100, 120, we've seen lines per hour. So that means, that he's fulfilling from just manual picking alone.
Right.
But now for the mistakes he made, that's actually lowering him down to like 90 or so lines per hour. And now somebody has to take that, fix the mistake, and then on top of it, that item now sometimes is lost and they can't even sell it because on the inventory on the website, it's not going to match. And in fact, a lot of our customers, the minute what they used to do is the minute their quantity count dropped below 5 or something like that, they wouldn't even put it on the website.
Out of stock.
So it was costing him money.
Right.
So that was like another like really major pain point, which is on the other side, which is the accuracy, the replenishment. And with our system, we're actually able to solve both. So the robots are able to replenish and pick. And in our world, in the facilities that we deploy in, we basically have sorters now. So they're not picking anymore. They're just standing still and they're sorting into multiple robots. And I can show you up some videos of that in action. And then on the replen side, they're doing more QC. So at the bay door, they'll basically open up their, for their truck, open up the boxes, QC, do whatever they need to do. If they have to have a barcode, but then when they're done, they just put it on a shelf that the robots on the back end will take that and go file it away.
Oh, okay.
So that you get 100% accuracy on where the totes are.
Right.
The robots do not make a mistake. There's no such thing.
No such thing.
Yeah. So there's only human mistakes. So the most mistake that would happen was, if somebody labeled it wrong on the intake, but that with barcode scanning, as soon as they put a new barcode, scan it, that goes into the system, so that eliminates that. But when the robots go in and put it away, that's actually one of their downfall and gain, right? Is that they don't think, and you tell them to go put it in that location, and they'll go put it in that location. There's no thing. Now, our robots have some capability. We use vision systems, so if there's another tote there,
it can recognize that.
So it can recognize and see. But then they stop. They're like, "Okay, you told me to put it in that location. There's a tote. What do you want me to do?"
Right.
That's where people come in. So, and we don't think that right now, and we're not even close to eliminating completely people and just have like a dark warehouse.
Yeah.
But what you can have is a warehouse that pretty much operates autonomously, and people are there to solve problems.
Right.
Robotics right now are not able to solve their own problems, basically. People have to solve
when they have a problem, they call for a person,
Exactly.
right? Yeah.
So we started this company, InVia Robotics, and to supply this basically goods-to-person system. And we looked at goods-to-person systems have existed for a while, shuttle systems. So Kiva was a goods-to-person system. And again, one of their biggest issue was the deployment. That it took just way too long. It was a construction project. So with our robots, we can do a deployment over a weekend, go into the existing infrastructure, existing shelves, existing totes. Most of our customers all use corrugated totes or suction cup are able to pick that up. Okay. And we're really able to solve their immediate needs and solve for their current problems as well as their future problems. So they don't have to install a system that will do their capacity 5 years from now, 10 years from now. They're installing a system that will do their current capacity. And then as they grow, they can add more robots. Or if they grow in space, they can add more shelves. So they have the option to do either. Okay. Now, on top of it, we actually are able to provide different workflows with the robots. And that helps you to justify the automation for the non-peak time. So at peak time, the robots are just concentrated on peaking, basically draining that warehouse as fast as possible.
Right, yeah.
But then at non-peak time, so 11 months out of the year, the robots are doing additional tasks, working extra shifts with nobody around. So for example, doing some of the replenishment, doing cycle counting, our robots are able to take the tote, weigh it, figure out how much is left in there. So go around and cycle count basically all the totes that the people just touched today and make sure all the inventory is correct. So providing other values, other workflows during non-peak time. In fact, we have a new workflow that we introduced lately, which is the L1 workflow. Okay. And that's extremely unique for our particular robot. And it's our ability to build a wall, a shelf, basically, that is just for the current orders of the day. So you can imagine the robots start at 5 in the morning.
Okay.
They go collect all the totes for those orders,
Right.
put them in one location. Now the people will come in at 8 o'clock, collect all those items, and now they're basically, again, just sorting it because all those orders are right there in front of them. And they can operate it actually at 400 to 500 lines per hour, so extremely fast.
Yeah.
And then basically go out and do packing. So now those people who just sorted are now doing packing. While they're doing packing, the robotic system is going and rebuilding this wall for the next batch. And when they're done packing, they'll come back, collect that, and then it can go back and forth. And you're utilizing this one person a lot more efficiently.
So it's kind of like a put wall, basically. Yeah, and then the robot is actually the one that's filling the put wall.
Exactly.
Right.
Yep.
Interesting. Okay.
And it's doing that basically in real time. So as orders coming in, it's placing it in. But the nice thing is that it's completely decoupled from the person. It allows the person to do other tasks while the system is basically working. Now at peak, that ends up being a bit too slow. So what happens is the robots are just bringing a tote. The person picks from the next one, next one. Our robots even on peak performance, they don't even stop. So we bring only one SKU, which again completely eliminates the mistakes because the person doesn't have any options. There's not like he has a bunch of other options. There's only one option, this one SKU, this one box that we brought, and then it will pick that, and then the next robot will come in, and you can think of sort of like a conveyor line that it's going through, and he's just picking from it and sorting, so we can get a person to operate at extremely high rates.
Pick one, moves next one.
Exactly. So that so between really training people and giving them a lot more efficiency to operate in the warehouse, and also decreasing the cost significantly, because now there is, like I said, over a weekend we do a deployment. We just did another latest deployment. It was actually some of the vendors that's on your shirt over there, and we'll be releasing a press release with them soon. But took less than a month to get the whole system with the integration and everything to get that up and running. So it was very, very quick for them. And again, supplying the current needs that they have, and will supply their future needs when they need that.
Okay. All right. Really interesting stuff. So I'm curious. What do you think about? We're day 3 here at MODEX. I'm sure you had some time, maybe to walk around, maybe not. But what are you seeing here that you think is kind of maybe the next thing in robotics and automation for warehousing?
So I have not had a chance to walk around yet. We've been pretty busy at the booth.
That's a good thing.
Probably go tomorrow, which is the vendors' time to walk around. But some of the stuff that I've seen, I think the most interesting thing that will start coming out is the fine manipulation. So getting a robot arm to actually go inside a tote and pick that and make that very efficient would be very good. So I know some people like right hand robotics or class 1 robotics are trying to solve that challenge. And I think once you can do that at both an efficient cost and at a high rate, you'll be able to fulfill basically 100% of the warehouse. So with our system, the robots will bring in the totes. We can actually bring the order tote and the tote. The arm moves it from one end to another, and now you have a full end-to-end fulfillment. And again, people will still be involved, but they're now involved in higher level decision making, higher level problem solving, and that's really where they need it. We don't need them to walk, day to day, 100 miles a day.
Just do the same thing over and over.
Exactly.
And over, right?
They're actually not good at that.
Yeah, we don't like that. Yeah, we don't enjoy that at all. So great stuff. So how can we find out more about InVia Robots?
So obviously you can go to our website, www.inviarobotics.com. We have a cool animation over there that actually explains all the different solutions that we provide, and I can shoot that over to you as well.
Okay.
And then there's more. Obviously, you can visit us at the booth on our booth number, but it's at the end where all the robotic companies are at. So.
Okay. All right. We'll get over there and we'll take some pictures, post them on social media as well. So we'll put out all the information about InVia Robotics on thenewwarehouse.com as well. So Lior, thanks so much for stopping by the booth.
No problem. Thank you very much, Kevin.